This is 7th grade activity 5.2. The objective students will develop an intuitive understanding about what happens to the perimeter and area of a figure when it is enlarged or reduced proportionally. The standard covered is 7G1. The page numbers out of the hardcover book are pages 200 through 205, and out of the practice journal, page 111 through 114. This is our activity, so you're going to go ahead and want to open up your book to page 111 out of your practice journal. Today, what we're going to be doing is we're going to be working with finding the area and the perimeter of figures as they are enlarged. Okay, so here's our first sample. We have a square, and our square originally was 1 unit by 1 unit by 1 unit. So whether these are inches or centimeters or whatever, if we were to do the perimeter, we would add around the outside. So 1 plus 1 plus 1 plus 1 gave us 4. So our perimeter on that small one is 4. Now remember, to find the area, we take the base times the height for a rectangle or a square. So 1 times 1 would give us 1 for the area. So that's how we're getting the area of 1. So now we're going to go ahead and continue this pattern. So now we're going to double each side. So now instead of it being 1, it's actually a 2 by 2. Okay. So if I go through and count how many squares there are, well, there's 1, 2, 3, 4, 5, 6, 7, 8 around the outside. So our perimeter is 8, or I could add 2 plus 2 plus 2 plus 2. Okay, now to find the area, it's base times height, 2 times 2, or we can actually count our squares. We have 1, 2, 3, 4, because we actually have that visual. So the area would be 4 units. Okay, so now we're gonna go ahead and triple the sides. So this was doubling it. This was double. Now we're gonna triple the sides. Okay, so if we triple the sides, now they are 3 by 3. So if we do the perimeter, there's 3, plus another 3 is 6. Whoops, I should write 3. Plus another 3 there would give us 9, plus another 3 is going to give us 12 for the perimeter. And our area, well, we can either do 3 times 3 is 9, or we can count and see that there are actually 9 squares here, so 9. Okay, so now we're going to go ahead and quadruple. Okay, so if we quadruple this, well, our side lengths are 4 by 4, so 4, 8, 12, 16. Every side was worth 4, so our perimeter was 16. Our area, well, we can either do 4 times 4, or we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Our area is 16 blocks. So that's going through and actually changing by doubling, tripling, and quadrupling the original. So changing the size, but still making them similar figures. Okay, so we're going to go ahead and practice that with some other figures. Okay, so we're going to go ahead and jump to one that's a little more complex. So we're going to jump, I want you guys to flip your page, and I want you to go to page D. Or page D, my goodness. Page 112. So on page 112, you have something like this. And on page 112, they say they want us to go ahead and continue what we were doing previously. Now, your choice if you want to go ahead and create that shape and go through and actually draw it out. I'm not going to say that you have to do that. So if I were to go through and continue the process that we did here, they're just saying the area is C or 1C. We can put a 1 in front of that. There's one of those parallelograms there. Why they chose C, I don't know. That's just how the book had done it. Okay, so if I were to go ahead and continue this pattern for this parallelogram, well, now we're going to have 2 of these across. And I'm going to experiment here for a second. Okay, so we're going to go ahead and have 2 of those. And actually, let's make this an infinite cloner. Not that you have to draw this, but I'm just kind of showing you that figure so that you can actually see the figure. So now when I go through and I do the perimeter of this, well, my perimeter is 1, 2, 3, 4, 5, 6, 7, 8. So this was doubling it again. Our perimeter equals 8. Okay, our area, well, how many of those little parallelograms did we have? We ended up with 4 of them. So 4, and we're just going to use a C like the book did. I'm guessing they didn't use P for parallelogram because of the fact that we're using P for perimeter. Okay, so now we're going to go ahead and continue that pattern. Once again, you do not need to draw the shapes. I know that that's going to take you more time. I will go ahead and do that so that you've got the visuals. So now we're going to triple the sides. Okay, so we're going to go ahead and do a triple of this. Okay, so we've got 1, 2, 3, and then we'll go 3 high. 1, 2, 3. Okay, so there's our figure. So perimeter, well, we've got 3 on each side. Okay, so 3 times 4 sides gives us, for our perimeter, we have 12. And for our area, well, we have actually 9 of those little blocks, or 3 by 3. So we have 9 C's. Okay, now granted, as we start working and we were to actually find the area of that that parallelogram, a parallelogram is not base times, or the 2 side lengths times each other. It's actually base times height, but for this situation, it'll work for us, okay? So now we're gonna go ahead and quadruple it. So I'm actually going to, for the sake of time, whoops. Do this. Okay, so just for the sake of time, I was doing that so that this would go a little bit faster for me. Oops, I accidentally hit my button there. Maybe I should play a little xylophone for you. Okay, so now I'm gonna finish this off with my 4th side here. Okay, so those are no longer 3s. Okay, so now we have 4, and I forgot to do my other 4, my 4th height. Okay, so now we've got our figure so that you can see it. We're 4 by 4 by 4. So that gives us a perimeter of 16 and an area of 16 again. C. Okay, so what I want you guys to do is you're going to go ahead and finish off working with letters B and C. Your choice if you want to draw the figures or not, or if you would rather just kind of go through and maybe jot out what the side measurements would be. I will leave that up to you. You do not have to draw the figures if you don't wish to for letter C. Letter B, the shapes are there. So go ahead and finish out working through that process. Okay, so now that you're finished, hopefully you would pause your video and you would work through that. We're just gonna go ahead and pull our information and put it into these charts. These are on the bottom of page 112 and the top of page 113. And on page 112, they were having us just pull all of our information for the perimeter. So this is my perimeter information. You can see perimeter right there. So my perimeters, I'm just pulling the information that I had from all of those figures where I went through and I wrote in their perimeters and their areas. So for my squares, I should have had 4, 8, 12, 16, okay? My triangles, I ended up with 3 and then 6, 9, and 12. And I'm just pulling this off of my figures. So this is not off the top of my head. I don't have this memorized. I'm just pulling it from my information on the pages that I just got done doing with those figures. So on my rectangle, we should have had 6, 12, 18, and 24. And then for my parallelogram, we had 4, 8, 12, and 16. Okay, so then when we went through and we did the areas of each of those. So for my squares, the areas I had were 1, 4, 9, and 16. For the triangles, I had they had it as a B, it'd be like 1B, and then 4, because it was 4 triangles, or 4B if you put the B's in there. 9 triangles when it was tripled, and then 16 triangles when it was quadrupled. And then for my rectangle, I had 2, 8, 18, and 32. And for my parallelograms, we had 1C, 4C, 9C, and 16C. Okay, so at the bottom of page 113, there's a question there. Question 4 says, in your own words, how do changes in dimensions of similar geometric figures affect the perimeters and the areas of the figure? So when we look at those perimeters, what do we notice about the perimeter? Like if you compare the 4 to the 8, what's it changing by? Well, it's changing by 4, right? 8 to 12, it went up by 4. And then 12 to 16, it went up by 4. So if we look at the triangle, for example, on the triangle, it went up by 3 every single time. Whoops. So on the perimeters, well, what do we notice about the perimeter? It changes by the same number each time. Okay, how about for the area? Are we noticing anything on area? Well, it went from 1 to 4, and then from 4 to 9, and then 9 to 16. So it went up 5. Well, the first one, it went up 3. It went up 5, and it went up 5. Okay, do we notice? So there's not a common pattern there, but if you took your side and went ahead and squared it, that would be changing it. Okay, so we're not seeing the same pattern when we do areas. So just because we double the areas or triple the areas, we're not actually going through and seeing that. What I am seeing here, though, is when we doubled it, we got a 4 answer on this one. And when we doubled this, we tripled our triangle, we got a 9. So 3 squared was 9. And when we quadrupled, or times 4, 4 squared would give us 16. Okay, so there I'm seeing it's actually doing something with squaring the sides. So area is, maybe it changes by the squared number. Okay. All right, so that's pretty much it for this activity. Once again, taking note that when you double or you quadruple similar figures, you do not just double the area. You do double the perimeter. That does change. You go through and you actually add that same number every single time. But when you're working with the area, it is not doubling the area. It's actually doing something more to that area.